Professor Oded Shoseyov, thank you for joining us in the evokeAG studio. What is the one thing you would hope delegates take away from your presentation today?
So I hope that the take-home message from my presentation today is that we can do everything in plants, and we are on the verge of the plant age. So not just making things that plants usually make, like food and materials for making paper or our shirts, but also plants can produce human collagen, for example, to make medical implants, so replacement parts for human being produce implants, and also humanized antibodies for drugs. So plants are really at the bottom of the food chain, and so they're the most efficient systems for production.
You've been talking about remarkable things, using plants to produce glass.
In fact, the plants are made of a nanofiber, which is an extremely strong material. And that nanofiber, when you process it right, it's totally transparent and extremely strong. In fact, it can make a film or glass-like material that is very, very transparent and extremely strong. So yes, that's one option.
So you work with Bio-Inspired Nanocomposite materials. What's that really mean?
Well, so I have to go back a little bit and explain why bio-inspired. Nature, over 3 billion years, developed the most amazing materials and structures that we wish we had in our possession, while we made inferior materials, synthetic materials, not sustainable, polluting, and don't really perform well. Take, for example, pump. We made pumps. They always need maintenance, lifetime maybe 10, 20 years. We have a pump here that, give and take 80 years if everything works well, 24/7. That's nature. Take computation, for example. We build wonderful computers made of silicon technology. But if you really want to get the strength, the computation strength of one human brain, the amount of energy that you will need to operate this huge computer is enormous. While you and I wake up in the morning, take a bite from bread or something, and we get all the energy we need to think. And so we need to look at nature and understand how nature does all these wonderful things. And so that's the biomimicry. And since nature makes everything from nanomaterials that self-assemble, then it all has to do with the nano self-assembly of biomaterials.
So I've read you're doing work with tobacco plants, nothing to do with smoking.
Right.
So give us an example using the tobacco plant. Sort of what are you doing?
So I can give you one example that we're doing with tobacco. In Israel, we grow tobacco that is genetically engineered with 5 human genes. They're responsible for making human collagen. And instead of extracting collagen to make medical implants as done today from dead bodies, dead pigs, dead cows, and human cadaver, we simply grow the tobacco, extract the collagen. The collagen that we purify from the plant is exactly the same collagen as we have in our body, except much safer and perform better. And from that collagen, we make medical implants. We have already 2 products that completed clinical trials and make sales in Europe and in Israel. So that's one example. Another example, if you want, we have another company called BioBetter that makes humanized antibodies, which are pharmaceutical drugs like Humira, indicated for rheumatoid arthritis, Crohn's disease. So these are materials that typically are not produced by plants, and definitely not by tobacco. And in fact, as you can see, we have now this slogan in the company that says that this is a tobacco that heals. So we are going to change the bad reputation of tobacco.
You mentioned they're genetically modified. We live in a time when there's more information than ever, but consumers seem to be fearing science which has been delivering us many breakthroughs. How do you feel we need to counter that? So, because the work that you're doing is going to be needed to feed the planet.
So I think that when we approach the market, we have to take in consideration that the general public should make his choice. And so, in our case, for example, there was absolutely no resistance because we came to the regulators, we came to the market and explained what we're doing, and we're selling in England, and we're selling in Germany and in Europe, in all places where GMO comes from, let's say, transgenic or genetically modified soybean is so opposed. But here, when you show them that, hey, this is a better alternative, it is safer, they understand it and they adopt it. So I really think that it's, first of all, matter of explaining what you're doing, what are the benefits, and if you do it right, then even in places like UK or Germany, people accept it.
Looking through some of the work that you've done over your life, I wonder when you actually get a chance to sleep. But I was reading about 4D food printing.
Yeah.
What's involved there?
So in the 4D printing, we're actually using a material called nanocellulose produced from one plant. On one hand, as a binder and as a material to make texture. Because as you know, if you really want to replace meat with meat alternatives like veggie burgers or veggie steaks, you really need to get the right texture, the fibrous texture that you have in meat. And nanocellulose has the ability to do that. So we developed a technology to really control, using that material, the texture of a printed food. Now, this is one part. You should actually ask me, what is the fourth dimension? Because, I mean, that would be...
I was waiting for it to hear that.
So the fourth dimension is really another element that you introduce into the printer, which is the cooking head. So this special cooking head enables us to determine the three-dimensional space of the printed product if we want to bake it or fry it or grill it. So now by doing that, all of a sudden we can get new textures and new flavors and new gastronomic sensations. Like, for example, now you can have a burger that is also crispy in the inside, not just from the outside. In fact, we can now print the French fries in the burger. So that's the fourth dimension, the gastronomic sensation.
So is the ultimate objective here to cater for personalised nutrition needs, or is it a more efficient way of producing food?
I think it's both. And in fact, when we thought about it in the beginning, we really thought about the first thing you were saying. So personalizing the food so people will be able to control the fat level. Because if I don't want to have 18% or 16% fat burger, and I really want to have like 6 or 4%, then now I can do that. Or if I want more salt or less salt, and if I want it more chunky or less chunky, thick or thin. So these are the things that has to do with the personalization. But what we found out that we are also doing some very important thing, and that is completely eliminating the cooling chain, because the cartridge that holds the ingredients can be stored at room temperature. So now you can deliver meat. It's not really meat, it's a veggie burger without at room temperature. So that will certainly disrupt the supply chain, saving a lot of money.
Will it be cheap to produce, though, in time?
Absolutely, it's already cheaper. For a simple reason, because we are producing plant material. Our protein source is plant, so we can use soy protein, we can use pea protein, chickpea protein, potato protein. and that's always cheaper than protein that comes from animal. And we're using a vegetable oil, which is also cost effective. And the nanocellulose is very, very inexpensive.
You're totally disrupting food delivery, though, aren't you? I mean, it eliminates kitchens, it changes the supply chain, it does a lot of things, doesn't it?
I don't think it will eliminate. I think it will change. I think that most people still would like the chance to stand in front of the stove and do things. But probably that could be done maybe in the weekend. But in the future, I can see where the dad or mom is still in the office, and they know that the kids are coming home at, say, a certain hour. They just take their smartphone, open the application, select the desired burger, also select the right composition, nutritional and so on, that fits both the taste and the requirements of the particular kid. And just 1 minute before he gets home, it's printed, ready for him, and also with a grill, you can write his name, so everybody knows, which burger belongs to whom. And I think it's great because, it will enable us to do a lot of things, and also to make the recipes more accurate. Because I'm sure you also experience once in a while when you read a recipe and you tasted that, but never exactly the same. But here it's a digital recipe. So it will be printed exactly here in Melbourne and exactly the same in Manhattan or in Tel Aviv.
There's a lot I could talk to you. I'll ask one last question.
Sure.
You strike me, Australia has over the years struggled a little bit with commercialisation. I was reading about you as one of your first ever papers. I think it was the transgenic eucalypt that you were delivering for paper production, and someone grabbed you and said, you need to put a patent on it. You seem to have grabbed that idea very well in terms of you're a researcher who understands commercialisation. Would that be fair description?
I think it would be fair description. I think that I personally got into the field of taking science into the commercial arena early in my career by chance. And I learned a lot because I was trained as a scientist.
Professor Oded Shoseyov, I could talk to you for a very long time. Thank you for your time joining us in the evokeAG studio, and all the best in your endeavours ahead.
Thank you very much.
Thank you.